Hello everyone. In the previous video, we have studied how to obtain the bilinear transformation using of digital filter for Butterworth low pass filter. In this video, we are going to obtain the digital filter for low pass Chebyshev filter. The question given is determine h of z for of lowest order Chebyshev filter to meet the following specification. 3 dB ripple in pass band when omega is greater than equal to 0, less than equal to 3 pi, 0.3 pi. At least 20 dB attenuation in stop band when omega is greater than or equal to 0.6 pi and less than pi. Use bilinear transformation. The given this is omega p and this is omega s. This is kp and ks. To obtain bilinear transformation, kp is equal to minus 3 dB, ks is equal to minus 20 dB, omega p is equal to 0.3 pi, omega s is equal to 0.6 pi. The first step in bilinear transformation is pre-warping. We have to find omega p dash and omega s dash. Omega p dash is given by 2 by t tan wp by 2. Substituting the value of wp as 0.3 pi, we get 1.019 radian per second. Similarly, substituting the value of ws as 0.6 pi, we get omega s dash is equal to 2.75 radian per second. In the previous videos, we have discussed the steps for Chebyshev filter, where we have to find the value of epsilon, k, d, etc. and then find the value of n. Similarly, in this Chebyshev filter, we are finding the value of selectivity factor k, which is given by omega p dash by omega s dash. We have found the values of omega p dash and omega s dash. Dividing both of them gives us the value of k. Discrimination factor d is equal to under root 1 minus delta p whole power minus 2 minus 1 divided by delta s whole power minus 2 minus 1. To substitute the value of delta p and delta s, we have to find delta p and delta s. Delta p is given by kp is equal to 20 log 1 plus delta p. Kp is minus 3. Minus 3, 20 comes to the denominator. This is log to the base 10. Hence, log inverse become 10 raised to this minus 3 by 20. So after using this formula, we get delta p is equal to minus 0.292. Similarly, delta s is given as 20 log delta s is equal to ks. Ks is minus 20 dB. 20 log delta s is equal to minus 20. Hence, delta s is equal to 0.1. After finding the values of delta p and delta s, substituting these values in the formula to find d, we get d is equal to 0.1. After finding the values of k and d, we can find the value of n. N is equal to cos inverse 1 by 0.1 divided by cos inverse 1 by 0.37. In the calculator, there is a button hyperbolic. In that, we can find the value of cos inverse, cos hyperbolic, which is given by 1.81. Rounding off it to the next integer, we get n is equal to 2. Now we have to find the value of epsilon. Kp is equal to 20 log 1 by under root 1 plus epsilon square. We know the value of kp minus 3, 20 log 1 by under root 1 plus epsilon square. Simplifying this by mathematical algebra, we get epsilon is equal to 0.995263. After finding the value of epsilon, we have to find the values of a and b. A is given by 1 by 2 into 1 plus under root 1 plus epsilon square divided by epsilon whole power 1 by n minus 1 by 2 into 1 plus under root 1 plus epsilon square divided by epsilon whole power minus 1 by n. After simplifying this by substituting the value of epsilon and n, we get a is equal to 0.45691 and b is equal to 0.65925. To find the value of a and b, the only difference is to find the a we have the minus term, and to find the value of b there is a plus term. After finding the value of a and b, we are going to plot a table. Since n is equal to 2, we are plotting the table for only k value as 1 and 2. Sigma k is given by minus a sine 2k minus 1 into pi by 2n, and omega k is given by b cos 2k minus 1 into pi by 2n. Substituting this in the calculator, we get, first we have to find the value of pi by 2n, n is 2, hence pi by 4 is equal to 0.7853. We have to feed the equation to find the value of sigma k. Feeding this equation in the calculator, minus 0.45691 sine 2k minus 1. I will take 2 as x, 2x minus 1 into the pi value is 0.78. Pi by 4 value is 0.78539. calculate at 1, we get minus 0.32308. Calculate at 2, minus 0.323. Similarly, feeding the omega k equation in the calculator, 1.099 cos 0.7853 into 2k minus 1. I will take 2x minus 1. Calculate when x is equal to 1, 0.771. Calculate when x is equal to 2, minus 0.771. We know that this is the real part and this is the imaginary part. Therefore, S1 is equal to minus 0.3028 plus j 0.771 and S2 is equal to minus 0.323 minus j 0.7771. Hence, the n value is 2. H2 of S is equal to Kn divided by S minus S1 into S minus S2. S1 is this and S2 is minus 0.323 minus j 0.771. Multiplying this polynomial equations, we get Kn divided by S square plus 0.644899 S plus 0.707838. The constant term we obtained is B0. In previous example, we have seen that when n is odd, the Kn is given by B0. In this equation, in this question, n is 2, which is even number. Kn is given by B0 is divided by under root 1 plus epsilon square. By substituting the value of B0 and epsilon in this equation, we get Kn is equal to 0.5017. Hence, H2 of S is equal to 0.5017 divided by S square plus 0.644899 S plus 0.707838. The steps involved in obtaining the transfer function remain same in analog and digital filters. Since we are asked to design a low-pass filter, we have to apply low-pass to low-pass transformation. Substitute S by omega p dash in place of S, we get S divided by 1.019. Substituting this in the formula in the transfer function, we get 0.5017 divided by 0.963 S square plus 0.6327 S plus 1.70783. We have obtained the transfer function in terms of S. Since we are designing a digital filter using bilinear transformation, the bilinear transformation equation is 2 by t 1 minus z inverse divided by 1 plus z inverse, where t is equal to 1 second. Substituting this bilinear transformation equation in place of S, we get, and after solving it, we get 1 plus z inverse whole square divided by 5.18519 z power minus 2 minus 15.3846 z inverse plus 11.6129. After simplifying it and keeping the coefficient of z power minus 2 as 1, we have to divide numerator and denominator by 5.18519. After obtaining this transfer function in terms of z, we have to substitute z as e power j omega, where e power j omega is equal to cos omega plus j sin omega. After finding this equation, we have to find 20 log h of omega when omega p is equal to 3 at omega p, and 20 log h of omega at omega s. Omega p given is 0.3 pi and omega s given is 0.6 pi. Hence, evaluating it at omega equal to 0.3 pi and omega equal to 0.6 pi, we have to obtain the approximate answer as minus 3 dB and minus 20 dB similarly.